Serengeti is an open source project that enables the rapid deployment of virtualized Hadoop clusters. In this demo, we show how Serengeti can be used to scale Hadoop compute capacity in and out in response to the workloads on the virtualization platform. One of the key advantages in virtualizing Hadoop is the ability to separate the Hadoop data and compute layers in order to achieve elasticity and more efficient hosting of multiple tenants. I've created two identical clusters using Serengeti, named DC-SEP1 and DC-SEP2, with data and compute separated. I've listed them here, and each cluster comprises single master, data, and client nodes, along with 8 compute nodes. Using the job tracker interface, I can verify that I've got 8 task trackers running in both clusters. I'm logged into the client node of DC-SEP1, and I'll run my word count job here. Let's refresh the job tracker interface again. Total submissions has been incremented, and I start seeing running map tasks. Now let's imagine a higher priority job gets submitted on the second cluster, DC-SEP2. I'm going to use the exact same word count job as before, purely for illustrative purposes. To accommodate the second higher priority job, I'll issue the cluster limit command to scale in the compute capacity on the first DC-SEP1 cluster. As Serengeti disables the compute nodes in the first cluster, we see the job progress start to slow. Serengeti reports that the compute node adjustment was successfully completed, and if we check the job tracker interface, it does in fact show the DC-SEP1 cluster with 2 active task trackers remaining. The higher priority job that was started later completes first, followed by the job on the scaled-in cluster. The cluster unlimit command removes the previous limitation on compute nodes. Let's verify from the job tracker interface that the cluster is indeed restored to 8 compute nodes. Our second cluster, DC-SEP2, also has 8 compute nodes. For completeness, we'll run a shorter word count example to see that identical jobs on the identical data compute separated clusters will complete in similar time. We've demonstrated how the elasticity in a virtualized Hadoop cluster can be leveraged to mix various Hadoop workloads. This concept can be extended to other scenarios involving Hadoop and other data workloads, as well as mixing Hadoop with non-data workloads. In all cases, the compute elasticity achieved through data compute separation and elastic scaling controls in Serengeti enable more efficient utilization of the available compute resources.